Welcome to qnawire.
All right, so in this circuit, so we have two parallel connected capacitors. So this is V, C1, C2, and we know that C1 is 35 nanofarads, C2 is 75 nanofarads, and V is 220 volts. Okay. In part A, we want to find out the charge stored in this in the whole circuit. So basically, we can determine the equivalent capacitance first. So CQ, because these two they're in parallel, right? So CQ is simply equal to C1 plus C2, which gives us 110 nanofarads. So the total charge stored in the circuit is Q equals CQ times V. Okay, and this equal 2.42 times 10 to the negative 5 coulombs. And in part B, we want to know the charges stored on each capacitor. Because we know that the Q equals C times V, right? So if V is the same, then Q is proportional to C. Then we see that Q1 is equal Q times C1 divided by C1 plus C2, right? So this gives you 7.7 times 10 to the negative 6 coulombs. And Q2 equal Q times C2 divided by C1 plus C2. And this equal 1.65 times 10 to the negative 5 coulombs. And in part C, I want to find out the total energy stored in the circuit. So total energy U equal half CEQ times V squared. Okay. So this gives you 2.662 times 10 to the negative 3 joules. And in part D, we want to find out the energy stored on each capacitor. So because in part B, we already figured out the charges on each capacitor, Q1 and Q2, so we can utilize the results. So U1, the energy stored in the first capacitor C1, equal half times Q1 squared divided by C1, right? So this gives you 8.47 times 10 to the negative 4 joules. And U2 equal half Q2 divided by Q2 squared divided by C2. And this gives you 1.815 times 10 to the negative 3 joules. Okay. And part E, we want to find out the potential drop in each capacitor. So because these two, they're in parallel, so the potential drop, they both equal to V. All right. So simply we can see that V1 equal V2 equal V equal to 20 volts.